Friends, today we are going to discuss about the chapter water technology. In that water can be categorized into two types. First one is soft water and second one is hard water. And we know that is the hard water what the elements causes means Ca plus 2 ions and magnesium plus 2 ions causes the hardness to the water. And and how the form will be exist in that water is it will be in the bicarbonate form, bicarbonates, chlorides and sulfates. In that hard water also we can be categorized into two types. First one is temporary hardness and second one is permanent hardness. And we have some removaling methods of hard water means by using some uh, experiments or some methods we can be converted into soft water. So those experiments and some methods are called it as a softening methods of hard water. And for temporary hardness, actually why it is called it as temporary and why it was called it as permanent. And temporary hardness will be caused by only bicarbonates, the bicarbonates of calcium and magnesium means magnesium bicarbonate and calcium bicarbonate, and these are easily can be softed means they by heating the calcium bicarbonate it can be gives the soft water. Means for example, let's see the equation. This is the formula for calcium bicarbonate, CaHCO3 twice. On heating it will gives calcium carbonate and water and evaporation of CO2 gas means carbon dioxide. And as for similar as per the magnesium also, and this is the magnesium bicarbonate and it is the magnesium carbonate and water and CO2. This is for Clerk's method. We call it as this methods means by heating the hard water we will get the soft water. This is called it as Clerk's method. Clerk's method. And we have some other other methods to remove the permanent hardness of water. Those are all synthetic reasoning method, ion exchanging method, Kalgan method, permutate method. Yeah, this is one point we have to remember, that is the permutate process can be otherwise known it as geolite process. Geolite process. Geolite process, process process. And now see one, actually in BTech we have a most common question, that is determination of total hardness. Now I will discuss this one, and remaining these methods means the removing of a permanent hardness I will discuss in the next video. So now I will go for the determination of total hardness of a given water sample. Yeah, here we have some experiment in the laboratory also, that is I will explain about the how processes only. Yeah, first of all we have to take the water sample of 50 ml. In that 50 ml we have to add 1 ml of ammonium buffer. Ammonium buffer means NH4 plus, NH4Cl plus and NH4OH, and this is called it as buffer solution. And one thing we have to remember, the pH of the buffer solution should be the 10. And we have to add to that solution in the conical flask 2-3 drops of the EBT. EBT means urochrome black tea. This is the full form of EBT, and this is the one solution. This have to be added in the solution. Actually, one question will be raised, why we have to use this EBT in the experiment. EBT acts as an indicator. EBT indicator. I will write here, EBT indicator. Yeah, and the entire the solution will be in the conical flask. The conical flask will be means the solution which is presented in the conical flask, that will be in the wine red color. That wine red color is the initial color. When we are titrating with the sodium EDTA, means I will show one structure of a EDTA. EDTA means ethylene diamine tetraamino of sodium. Means I will draw one diagram of this one. And ethylene means CH2, single bond CH2, and amino means nitrogen groups, and this one is nitrogen, and aceto groups means here CH3, CH2, COONA means we have taken sodium EDTA, so one side will be this one, and this is CH2 COOH. And for this, the opposite side means the stereo will be there, that is CH2 COONA, this is, and this is CHA3 COOH, and this is the structure of NaEDTA, and this have to be very important as per the exams and some competitive exams also. And from the come to the experimental part, when we are titrating with this one, means we have taken 0.01 molarity means the concentration, means the strength of the solution. The strength of the solution is 0.01 molarity. And finally, when we are titrating with this, we get some blue color in the conical flask. When we are actually in the titration, we have to mix the solution which is presented in the conical flask. That will be the end point, means the blue color. When we are getting blue color, that will be the end point of that observation. Actually, we have to do this one for 3 times, means we have to take the solution in the 3 times. So as I have given a one tabular form for the experimental, means the practical purpose. And when the practical question, in first observation, the initial will be 0, and the final means the burette reading will becomes to 8.5, means the difference between initial and final is 8.5. and this one 8. And the second observation also I have taken, means the final from this it was started, means 8.5 will be the initial, and 17 means the final reading. Means at this point we are getting the end point in the conical flask, means we have taken the 3 conical flask solutions. For this it will be repeated for 3 times, and we have to take the difference of this thing, means the difference in the initial and final volumes, and that will be the mean of that volumes, and that will be used in the calculation part. And finally we will get the answer of the hardness, means total hardness of the sample, means given sample, means we have taken the 50 ml, right? That 50 ml. So actually the formula is S1. S1 means the strength of the EDTA, strength of strength of Na to EDTA means here we have taken 0.01, and the mean volume is 8.5, and this is 1000, and from here we will get 1 by 100 here, 100, and this is 8.5 by 1000, and from here also we can take this another, we can have 85 into how many zeros, 6 zeros in 10 power 6. Yeah, this is the total hardness of the solution, hardness. hardness of the solution in as per moles this is. And we have some we can express the hardness in the ppms also, means parts per million. For parts per million we have to go through one method. I will explain in the next video. And thank you, and do subscribe and support me. Thank you friends.